CIEL is one of the UK's 4 agri-tech centres. Together, we need to ensure that we can feed a growing world population in a way that consumers expect. So safe food produced to a high standard in a transparent way and which leaves a responsible environmental footprint. We need to apply scientific excellence to deliver on this challenge, and we want the UK to lead in this field. CIEL is at the heart of ensuring the livestock industry is efficient, sustainable and competitive. We help bring new technologies and processes to livestock food production, from pre-farm gate through to the finished food product. We're the link connecting industry, the research base and government. Our aim is to reduce fragmentation in the sector and sign businesses to partners and research capability who can help deliver solutions. Together with our partners, we've delivered the greatest investment in livestock research capability in a generation. This is now supporting innovations to directly benefit the UK's livestock food supply chain. We can link you with this new research capability and insight, bringing new skills and resource to your own business research challenges. We will help you connect with potential partners and build the best project group, widening your opportunities to collaborate in research. We can help you make the most of your R&D budget, from identifying possible routes to funding to project management. CIEL looks to ensure important livestock issues are addressed and champion new ideas, providing a shared voice to inform and influence industry priorities. We can help you deliver the products and services your customers want, driving the livestock sector to be more efficient, profitable and resilient.
CIEL works to support and deliver industry-led innovative livestock research. We act to bring together as a central hub industry to academia. I just want to introduce now some of the great new expertise and capability that we have.
So we're at the University of Nottingham Centre for Dairy Science Innovation, where we have some brand new state-of-the-art research facilities for use in dairy cattle. We can conduct research right through from calfhood, young stock, through to adult dairy cows. So our main themes of research are dairy cow nutrition, the impact of the housed environment on dairy cow health and well-being, and we've got a Containment 2 unit where we can look at the physiology of how cows respond to certain diseases.
Through nutrition, we're interested in increasing feed efficiency of dairy cows and also reducing their environmental impact. And to do this, we measure the feed intake and we also measure methane emissions during milking. We can test a whole variety of feed ingredients, looking at novel products such as distillers' grains and looking at feed additives that will improve the feed efficiency of cows and improve their fertility and milk production.
Here's the containment facility, which is principally going to be used for investigation of intramammary infection and mammary gland biology. One thing that we're really keen to do is to identify the parts of those bacterium that can be susceptible to new therapeutic agents and identify the components that we could include in vaccines in the future. So in this facility we'll investigate bovine mastitis, a major problem for the UK dairy industry. There's about 1 million cases occur every year, with a loss of about 1 million tonnes of milk and the use of antimicrobial to treat every single case.
Precision technology is a growing field over the past decade. So what we do here is we not only use various technologies that can give us information about animal health behavior, but we also work with industry to develop some novel technologies and develop novel algorithms that can help us to predict cattle health at an early stage.
Well, we're here at the Leeds University Farm, and this is the only outdoor research facility throughout Europe. This is a unique facility because it combines both an outdoor sow unit and an indoor sow unit. We know that piglets raised outdoors are more robust and resistant to diseases than piglets that are raised indoors. And the only way we can identify just why those two are so different is by looking at how they develop in facilities running side by side with similar feeding, management, so that we can identify what it is about these piglets that is different from the two systems. We're in the process of expanding our indoor research facility so that we will be able to run really well replicated sow nutrition trials. Modern sow genotypes are very different to the sows of old, and hence we need to work out how best to feed and manage them going forward into the future.
We're uniquely placed in that we individually electronically identify all of the pigs on our farm. That's piglets, sows, all the way up to slaughter. Having this electronic sow feeding system means that we can add another string to our bow, in that we can feed each sow according to her individual nutritional requirements. We can feed 2 diets or a blend of 2 diets, so we can perform some quite in-depth trials in an automated fashion, whilst maintaining all of the animals within one group. So all the data from the electronic feeders comes back to the computer, which is then networked. It allows us to marry up all of the data that we collect from the electronic sow feeders in real time with all of our historical data and the data of the performance of the piglets from each individual sow.
If we can feed each pig according to its own requirements, then we will reduce the costs of production, we'll improve feed efficiency, and we'll also reduce our environmental impact. All things which the industry is very keen to do.
We're here at the University of Bristol Vet School, which has been funded through CIEL and the university with assistance from Innovate UK, and it's available for industry to use for research purposes.
This is a farm, but it's a research farm, so we've got a lot of flexibility. We can run both broilers and laying hens in here, and we've got specialised equipment for both. We've got 8 rooms, and they're all individually isolated, so we can control the temperature, the lighting separately, we can control ventilation separately. We have a world-renowned behaviour and welfare group, as well as immunologists and microbiologists, and we also work collaboratively with other CIEL poultry facilities.
We're in one of the laying rooms now, and one of the projects that we did in here is looking at keel bone fractures. The keel bone fractures affects somewhere between 60 and 90% of laying hens in commercial flocks. And of course industry is very keen to reduce this because it's a major welfare issue, and it also potentially affects productivity as well. And what we have here is some footage showing how the birds transition between different parts of the room, particularly the kind of high perches, how much time they spend on the litter, how much time they spend on the slats. So we're basically trying to get an idea of whether it makes any difference to the behaviour of the hens as a result of having a keel bone fracture. The next study we're going to have in here is feeding insects to chickens. Insects provide a sustainable food source for chickens and crucially do not involve the consumption of food that could otherwise be given to humans. Because these will be live insects, and chickens are very keen on foraging for live insects, and that could be a very beneficial thing from the point of view of their behaviour.
Birds probably see the world in a slightly different way to mammals. They have 4 receptors, and mammals, like humans, only have 3, so they see a different spectrum of light. That is quite important to how they detect things like colours and feather patterns on other birds. So the study we're going to be doing is looking at specialist light frequencies for broiler production. They behave in different ways under different types of lighting. And if you can provide them the closest to their needs, then you can influence the behaviours, you can probably influence what they can see, and there may be effects on production and positive effects on welfare and behaviour as well.
Northwick on the edge of Dartmoor is the world's most instrumented grazing farm platform. The farm there is split into 3 farmlets with lots of different instruments for measurements on each of those to compare all sorts of things to do with nutrient fluxes, greenhouse gases and soil and temperature.
We're here at Cocker Park Farm and we're looking at the CIEL facility, which is a new facility for us. The feed mix and delivery system that we've got here, it combines a number of technologies. Firstly, the multi-fire system, which draws different ingredients or different feeds from the silos on the end there, mixes it and then delivers it to whichever hopper you tell it to deliver it to. We have an option to have a need-up feeder. And need-up feeders are electronic feeders which will identify each individual pig. It will then weigh that pig each time it goes into feed, tell you how much feed it's eaten and how long it spends feeding. So it's a tremendous amount of data that can be collected and really useful for people like feed companies, etc. Newcastle University's research has always been about the industry and things that we can use within the industry. The gait analysis, for us, it's been used as a predictive tool for lameness in sows. We want to be able to identify it so that we can treat animals early, which is obviously better for the animal, for its welfare, but also from a production point of view, we can lose those animals out of the production system that are prone to lameness. It's borrowed technology really from the animation industry and filming industry, like gaming and so on. Films like Avatar would have used this technology. We use the reflective markers and we get an image that comes up on the screen that looks basically like a skeleton, and we can use that data to be able to accurately measure differences in the gait and also in the angle of the joints and so on, which is a predictive sign of illness. We used Louisa there as a model for demonstrating the equipment, but this shows you the kind of image that you get from what we did. Each of those markers that were on the joint centres can be joined up to make basically a skeleton walking across the screen, and then you can have accurate measurements between those markers, which tells you if there's change in the way the animal's moving over time, and which could be a good indicator of potential lameness. So what we want to do is develop a system that is a simple camera put on a wall above a race that will do the same job as this equipment, but it's easily affordable and anybody can have access to it.
CIEL is a government-funded, industry-led collaboration between 12 of the leading UK academic institutes and universities and a wide range of industry stakeholders. CIEL's main aim is to uplift the productivity and profitability of UK livestock farming in a sustainable manner. CIEL started in 2016, and the government funding has been used to invest in the capability and capacity of research facilities for livestock across the UK. CIEL's investment and membership is driving globally cutting-edge research into farm production systems and enabling a faster uptake of innovation across the livestock sectors. At AFBI Hillsborough, investment has focused on technology, which is identifying opportunities to increase the technical efficiency as well as the health and welfare of dairy and beef cattle, sheep and pig systems, whilst reducing their environmental footprint.
Within our calf house, the staff are assisted by new technology purchased through Innovate funding through CIEL to effectively manage the performance and monitor indicators of calf ill health.
We have recently installed bespoke concentrate feed systems which can dispense 4 different types of feed to tailor individual animal diets. They measure the full body live weight of each calf to correlate with the intake recorded. With these systems alongside our automated milk replacer feeder enable us to measure the precise nutritional requirements to manage heifer performance.
This feeder allows us to measure the live weight of each heifer as it visits the feeder and also measure and record the water intakes from each animal. The feeder will dispense 4 different types of concentrate to allow strategic supplementation at grazing.
We have recently installed the UK's first electronic feed and water intake monitoring system, and this system that you can see behind records daily and individual feed intake as well as animal weights. We have 4 replicated stations so we can monitor up to 50 animals at a time. So these recent installations really mean that AFBI is very well placed to evaluate innovations in farming practices that would enable us to improve efficiency.
One of the main areas we're currently involved in is trying to improve the precision with which we feed dairy cows, and absolutely key to that is being able to record the intake of each individual cow accurately throughout the day. Through CIEL funding, we have purchased 36 of these individual cow feed intake monitoring boxes, which allow us to record total intakes, but also the behaviour of cows over a 24-hour period.
We purchased a number of new precision technologies to allow us to better assess animal behaviour. These pedometers allows us to look at walking times, standing and lying times and animal steps. So this gives us valuable information on animal health for our research studies. Another one of these technologies is this rumination halter. These give us an in-depth look at the rumen function and the eating behaviour of the cow. At present we're using these to assess diet quality.
As part of the CIEL investment here at AFBI, we are currently in the process of constructing a precision grazing platform. This platform will occupy a proportion of our grazing platform here at Hillsborough, and it really will be an instrumented farm platform, a connected landscape if you like, lifting detailed measurements of both soil, plant and animal data. As part of this, we are using our CIEL rumination halters and lying time sensors to understand cow behaviour at pasture. We'll also be using a series of weather stations and soil sensors to monitor grass growth conditions, and we're just starting some work to evaluate the role of drone technology and reflectance imaging for assessing pasture yield and quality.
These rumen temperature boluses have been administered to the calves at 3 months of age. This will pick up temperature every 5 minutes. That rumen temperature is transferred from the bolus within the animal to this transponder that is within close proximity to the shed or house or field that the animals are in. The data on this is then transmitted to the cloud, and then from the cloud to either our computer or a mobile phone. This equipment has been funded through CIEL and will benefit the beef industry through improved animal health and production.
The unit has a range of specialist equipment and facilities, including those funded by CIEL, dedicated to the specialist studies undertaken. The wet and dry feed system across the weaning, growing and finisher accommodation allows automatic supply and recording of feed and water inputs to all pens. Up to 20 dietary options, 3 micro-ingredients and blends of diet can be programmed to be automatically supplied into individual pens according to nutritional or experimental needs. This enables AFBI to undertake a broad spectrum of nutritional and production-related research for pigs across both wet and dry feeding scenarios. The DEXA scanner allows us to apply technology from human medicine to non-invasively measure body fat and lean content and bone density from growing and finishing pigs. This allows us to monitor the impact of diet or genetics and body compositional changes through an animal's life. The scanner can also be used in animal carcasses obtained from the abattoirs. We have a high-resolution infrared thermographic camera which records surface temperature. With such technology, we are able to take measurements of animals' physiology, health and welfare. These include monitoring thermoregulation capacity of newborn piglets, local inflammation as a result of disease, body surface temperature and environmental parameters related to housing and management.
Plasma makes up around 99% of the observable universe, such as stars and lightning. Scientists have been able to generate thermal plasma for years at high temperatures for use in a range of industrial applications, including sterilizing surgical instruments. But recent advances in science now mean plasma can be created at room or body temperature, enabling it to be used in many more applications. Cold plasma has antimicrobial properties that can destroy harmful pathogens and bacteria that are resistant to antibiotics. There are many potential applications for agri-food. Because cold plasma is effective at tissue temperature, it could be used to treat chronic bacterial infections in livestock. This would reduce the reliance on antibiotics. It could also help with farm biosecurity, offering an alternative to disinfectants and for decontaminating air in livestock sheds. Harmful bacteria and pathogens in food could be destroyed with a simple cold plasma tool during processing. This would avoid food having to be treated to high temperatures and help increase shelf life. Importantly, cold plasmas leave no chemical residues behind, as antibiotics and conventional biocide treatments do, making them a safer treatment in food production.
Could cold plasma be the future of pathogen control?
Certainly, research is providing the evidence to support this theory, and the Institute for Global Food Security at Queen's University Belfast has world-leading expertise in this field. The cold plasma market is estimated to be worth £39.3 billion by 2026, driven primarily by applications within the agri-food sector. £450,000 has been invested by CIEL through Innovate UK funding and Queen's University Belfast to help create AgriPlas. The centre will enable cutting-edge research in novel methods to reduce animal disease, antibiotic use, food contamination and waste. AgriPlas will include a pilot cold plasma facility for industrial evaluation of this pioneering technology.